Hello, Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. And today we're going to talk about near vertical incident skywave propagation, or NVIS for short. Some people call it NVIS, but I don't know. It took me a while to figure that out when somebody called it that. But NVIS, Near Vertical Incident Skywave Propagation. This comes from Shawn, KB4 KGB. And he says, it would be nice if we could extend the HF NVIS operation to a practical mobile installation in order to make statewide contacts without using a repeater. I was wondering if the restrictions inherent in a mobile installation, such as antenna size, elevation efficiency, vehicle ground plane, power levels, etc., are just too difficult to overcome for possible NVIS operation. Are there any designs for HF mobile antennas for 40 meters which might provide acceptable results for NVIS? There's a lot going on in this question. Let's see if we can unpack it. First of all, near vertical incident skywave propagation means propagation, usually on 80 or 40 meters, sometimes 60, that goes up, bounces off the ionosphere, and comes back down. Now that would be vertical incidents. This says near vertical, actually up to about 45 degrees or so. This transits the D layer and goes up to the F layer and comes back down. If the frequency is higher than 40 or 80 meters, you have the problem that the signal will just go straight through the ionosphere. And that's not any good. Hence, we need to use the lower frequencies. And the thing that's very important to remember about NVIS is it's almost always done with horizontal polarization. So like a dipole. Now, the closer you bring a dipole to the ground, the more it tends to radiate straight up. At its optimal height of a half wavelength, it'll radiate out like that, out to the ionosphere and so on. But as you lower the antenna, you bring these patterns into the point where it's pointing straight up, which is just what you want it to do. Often 80 meters is used at night and 40 meters is used during the day. 60 meters becomes more interesting because there's been a recent change in how hams can use the 60 meter band. There's been a little bit wider space, about 15 kilohertz, where we can put different kinds of signals. Up until now, we've had to be precisely on one of 6 different frequencies, all upper sideband. And if you wanted to do CW, you had to go straight down the middle of the band and so on. That's been eased. That will see more people get on 60 meters. So let's talk about horizontal propagation. An 80 meter dipole full length is 40 meters, about 120 feet. So if you can rig up something on your car, pointing forward and then pointing back so you can get 120 feet of wire, well, it's not going to work real well in a mobile environment, is it? Even 40 meters, it's 66 feet for a half wave dipole. You're not going to put something 66 feet long up above a vehicle. So this brings us to the next thing, which is portable operation. Now, in portable operation, this is something that can be done fairly easily. There is available from DX Engineering, and I printed it out today. This comes from their technical support section, okay? And they've got this little paper describing near vertical incident skywave propagation and how to duplicate an antenna that's used by the U.S. Army for NVIS. Let's take a look. This is their WP-NVIS Rev 3, okay? And you can see a picture of it here. And this is not some huge thing. This is actually quite small. They talk a little bit about NVIS right here. And what's cool about it is you can be down in the valleys, okay, and still talk to each other. I have used NVIS to talk all the way from my location to Denver, which is about 200 miles as the crow flies. Okay, so that worked very well. Here is typical vertical radiation pattern that you would kind of like for NVIS. The 75 meter band or the 40 meter band, and you see you get the most pointing straight up. If you go up to higher frequencies, it starts to just act like a normal antenna. So this is the antenna that the Army makes. It's the AS2259/GR. And they say, well, we can build one of those. It's designed for military use from 2 to 10 megahertz. Some references say higher, but they will do the job very nice. We have this based on the information provided for the antenna. It's dual band inverted V at only 15 feet high. The area required, the footprint, is about 45 feet square. The mast is fiberglass to avoid signal coupling from the low antenna wires. And you've got sort of a cross. Now you're going to need to use a tuner with this, probably a wide range tuner. Simple tuners that are available for ham radio with an SWR meter in them are available for on the order of $100, and you can get them. They're manual, but once you're tuned for that particular frequency. This is a contest station where they are using this NVIS antenna. Now, they show you here the parts to buy. A lot of these you can get yourself, okay, make yourself. And this shows the center of the thing, how the coax comes up, okay, is hooked to the two antennas. Now the two antennas are crossed from each other. So here's a side view, 15 feet high, 25 feet, 25 feet, or here it is on 80 meters, 38 feet, 38 feet. Give you all the dimensions. This you want to be some kind of cord, not parachute cord, because that stretches. And this is what the center T looks like. So you are creating a crossed antenna. This is a fan dipole, okay? It's like a fan dipole. And this shows you different parts that you can use. You can, of course, make your own, and they have step-by-step instructions for how to build this. So, if you think portable, this is very easy to set up. You can get, a couple concrete blocks or extra heavy bricks or something like that to hold these out, and then just stick this on the ground, and you've got your cable right here. Run it down the center and out to the sides so it doesn't interact so much with the others. No radials required. Okay, now you will need to use a tuner with this because the lengths are rather short for what we would normally expect. Okay, now this type of antenna can move very quickly. I saw a drawing of a military truck that basically was like a van, okay, and your wheels here. And on these, on the bumper, they would have vertical antennas. This was from the Vietnam era, okay. What they suggested you do is grab that vertical and bring it down to the ground so it looks like this, okay, and held down. That will give you more horizontal polarization. Okay, that won't be as good as the separate antenna, but it's a good start. So here are the things that you need to remember. They're horizontal, okay, horizontal propagation, and low to the ground, anywhere from 1/10 to 1/4 wavelength high, kind of tending in this direction. This 15 feet right here is kind of tending more toward that. Set these up, practice them. I think you'll find that they do well. Do not try to use one of these for the first time during an emergency. You need to practice that. So a lot of people try to use this type of portable antenna. You could string up a full 40-meter dipole, 20 feet on each end. If you take two lengths of chain link fence steel top rail, they're a little over 10 feet long each, and one fits into the end of another. You can put that up, guy it, okay, and then stretch a 40-meter dipole in between, and you've got something fairly good for use during the day. Now again, you're out to your 66 feet. This antenna they describe here takes far less space, but you run into the problem, you do need an antenna tuner. Now, what kind of antenna tuner? This is the first thing I ever bought that was MFJ. I got it down at HRO in Denver. And it is just a tuner. And it's got your antenna capacitance, transmitter capacitance, and a switchable inductance. And that's all you need. This is a wide range tuner, and it's on the order of $100. You can get something like this. MFJ doesn't sell their products anymore except for a few leftovers. But you can get ones like this with an SWR meter built in, or you can just use the SWR meter in your rig. Now, don't use a separate external antenna tuner at the same time that you use the rig's internal antenna tuner. Turn the rig's internal antenna tuner off and then use the external tuner. There's also a spot right here where you can connect this to ground. If you're operating portable, grounding is not something that's easy, and you don't want to have to drive a 8-foot ground rod every time you want to operate portable. For one reason, you could damage the underground infrastructure like sprinkler pipes, water pipes, and so on. And second, there's no way you're getting that pole out of the ground by yourself. What I've seen the Army do is they use the old-fashioned kind of automobile wreckers that come in and lift up the front, haul them away. That can lift, a couple thousand pounds straight up. They attach that to the ground rod. They pull them up that way because in the Army, where they do their field practice, they're not allowed to leave the ground rods behind. They have to completely clean the site out for environmental reasons. Plus, they tend to use the same locations, and it's just too easy to attach to a ground rod that's already there. So I think, Shawn, that should answer your question. You're down in Georgia. I think you'll find plenty of trees you could lay it out to also. But there you go. A low, horizontally polarized antenna. 80 and 40 meters. You can try 60 and see what you get out of it. So there you have it. Until we next meet, 73.